Hi. So today I want to walk through what it's like to set up an EKS cluster using a mix of a hybrid cluster, using a mix of both AMD 64 x86 nodes and ARM 64 nodes. Amazon just released this Graviton2 processor, which is, they claim it's 7x more performance, 4x more cores, 5 times faster memory, and two times larger caches, and it's cheaper to run. So it's interesting to start experimenting. Kubernetes, a lot of container images have multi-architecture images available now. So never done this before. We're going to try it out, and we're going to see what it's like to take and set up a demo cluster on EKS using eksctl, the official command line for EKS, and create a Kubernetes cluster that has a hybrid of both traditional nodes and ARM nodes. So I think we're going to go with some M5 large nodes and some M6G large nodes as our combination. So to get started with, I'm going to hop over here to the command line, and I have the eksctl command line installed, and I already have the AWS CLI installed, and I'm authenticated. So we're going to just follow the EKS standard instructions and just create a very simple cluster. I'm in the US East 2 region, Ohio. I provided no command line arguments or anything here, so this is going to be the defaults. This time it's Kubernetes 117. It's going to create a cluster called Hilarious Mushroom with a bunch of numbers after it. Unmanaged nodes. And it's going to create I think this is going to create a 2-node cluster by default. And this takes about 15 minutes or so. So while this is running, I'm not going to make you sit here and wait for 15 minutes. So nothing's going to happen on the command line. We'll skip ahead. All right. And so that finished. It took about, 10 to 15 minutes. And we now have a cluster. It's called Hilarious Mushroom. And if I look, get nodes, I have 2 nodes that are running. Let's take a look what else we have. We have a really plain basic cluster. And let's take a look in the kube system namespace here. So here we have a couple interesting things. The kube proxy daemon set is running. Oops. We're going to take a look here at what daemon sets are deployed into the kube system namespace also. So the kube proxy daemon set is running across both nodes. AWS node, which is the CNI plugin used for AWS VPC networking inside the cluster. That's a daemon set. You can see we have a pod running on each node there. And core DNS, which is just a deployment, but it's running with a replica count of 2 also. So this is great. And if we look at one of the nodes that we have, let's take a look at this node. Let's describe node. And we come up and look at the labels that are in it. And you can see that it's created a Kubernetes IO architecture label set that to AMD 64. It also sets a beta Kubernetes IO arch equals AMD 64. So we have 2 nodes. They're both AMD 64. They are M5 larges by default, I believe. M5 larges. EKSctl sets those as, or EKS sets them as a label also. So great. It's pretty basic, easy to set up a EKS cluster. The next thing that we want to do is add a new node group into our cluster. So if I do eksctl get node groups for my cluster named Hilarious Mushroom, you can see that I have a single node group, and that node group has a min size of 2, a max size of 2. M5 large is using this AMI. So I'm going to add a second node group because all instances in a single node group have to be of the same type from the same AMI. And of the same instance type. So we're going to create a new one. The first step is going to be to figure out what AMI we want. So to do this, let's type eksctl create node group. And we're going to add it into that same cluster. For the instance type, we want them to be M6G larges. These are the new Graviton2 instances that are roughly the same class and equivalent to that M5 large, just the ARM version of it. And we have to specify an AMI because eksctl will try to auto detect an AMI, but it won't detect an AMI for an ARM instance right now. So how do we figure out the AMI? That's where things start getting interesting. So if we come here back to the web and we say AWS, EKS ARM AMI. So they have an ARM support documentation. Let's take a look here. Probably should have started here. This is interesting. It says that it only supports Kubernetes 1.15 or 14, and we're on 1.17. So if this works, it's not going to end up really supported that well. And we're not following these instructions. We're kind of following our own instructions. So to do this, let's. This is interesting. That's great. Let's actually search for EKS AMI. So Amazon publishes some EKS optimized AMIs. And these are Amazon AMIs based on, the ones that I'm using right now are Amazon Linux 2. And by optimized, they have a few things like the kubelet already installed, Docker, AWS, IAM Authenticator, and all the components that are necessary to have it join the cluster so you don't have to do anything additional. But we're looking for the specific AMI ID. So if we come down to here and we look, we can just copy this. It says here's how you can look up that AMI ID. So we'll do that. It takes us into AWS System Manager. Oh yeah, unknown region, because the last parameter said region code. So I'm going to come over here and change this to US East 2. This shows us the AMI ID here for Amazon Linux 2 for Kubernetes 1.17, but it's not the ARM. This is the AMD 64. This 044 is going to be the same AMI ID that we're already running. So how do we get the ARM version? I haven't found a way to do this according to the documentation, but I did actually. It's interesting if you come up here to the URL and where you can see here we have Amazon Linux 2 in the path in parameter store. And if I just tell it that I want ARM 64, this opens up a different parameter for Amazon Linux 2 ARM 64. The parameter exists and it has an AMI ID, and this is in the US East 2 region. So let's just go ahead and try that one. A little bit of kind of making it up right now. So we're going to add this node group and see if this works. And so this added a new node group into our cluster with that AMI ID, and it's deploying it through CloudFormation, and right now it's waiting for the nodes to be available. This doesn't take as long as creating the original cluster, but it does take a little bit of time. We're going to fast forward to when this is done. All right, so now we're just waiting for these nodes to become ready. The node group's created, and we're just waiting for them to join the cluster. This can take some time, and also there's a lot of room for error, like in different problems when this happens, networking problems or IAM roles and various issues. So let's take a new window here while we're waiting, and come over and get the nodes in our cluster. And so it's great. We have 4. That's good. So the Kubernetes API server, the control plane is aware of our 2 nodes, but these say not ready. So why is that? So when we look at to try to describe that node, what are we seeing? We're seeing started kubelet, sufficient memory, no disk pressure, sufficient PID. No real problems. Interesting. So let's take a look at all the pods and all the namespaces. I have no new pods running because they haven't changed. Great. So we'll wait a little bit, see if this ends up joining or timing out. Oh, actually, look, we have a problem here. Runtime network not ready, CNI config uninitialized, the network plugin not ready. So I think this is a problem that the AWS CNI plugin by default isn't going to run on those ARM nodes. So we can just kill this for now. And one of the things that we may want to do, the EKS created the cluster for us with CNI enabled, and it just used the AWS VPC CNI plugin for overlay network. One approach to help solve this might just be to switch to a different CNI plugin for now. So let's an easy one would be weave. So weave CNI on Kubernetes, and let's take a look at the docs for this. So weave can be installed onto your CNI enabled Kubernetes cluster with a single command. Let's just grab this and try it. This is just a test dev cluster, so we'll see what happens. Let's go ahead and install this CNI plugin. Okay. And come over here. So I have 4 weave nets and still 2 AWS node ones. And interestingly, I also don't have 4 proxies, which I should have one on each of these nodes because that's a daemon set. And core DNS is okay because that's just a deployment. But these aren't all ready. One of them was ready. Let's see what we get if we run it again. So now we have, I'm going to make this window a little bigger. So now we end up with 2 of them are running and 2 aren't, which may very well be, let's actually go -o wide on that so we can see where they're running. So the one that's not running, they both restarted, and it's on node 106 and 88. And so if we do kubectl again nodes, we can see that 106 and 88 are the 2 nodes that aren't ready. So those are the 2 ARM nodes. Interesting. So weave isn't running properly. Let's take a look at why. Kube control logs. Oh, there's 2 pods, so we'll take a look at our 2 containers. Let's take a look at the weave logs. Nothing. The weave NPC logs. And here we have something. It is unable to communicate with the Kubernetes API. It's getting timeouts communicating with the Kubernetes API server on the control plane. Interesting. That could be related to the fact that there is not kube proxy running everywhere. So if we do kube control get daemon sets in the kube system namespace, you can see that kube proxy it's only set to 2. It didn't scale up to 4. Let's take a look at that kube proxy daemon set and try to look why. Yeah, so here in the daemon set template, there's a node affinity to match architecture of AMD 64 in Linux. So this is properly scaling up to 2 because those are the only 2 that have that. So we're not going to make any changes to that. I have a gist here, though, that we might be able to use. This gist is, it's a copy of the existing daemon set for kubeproxy, renamed to kubeproxy ARM. Deploys into the same kube system namespace. The only real difference here is that it has the architecture set to only run on ARM64, and then it has the kubeproxy ARM64 image, and this is probably the wrong version of it. So let's actually grab this and actually just make a new one. So come into here, and so we need to update that version from 1.15.10 to match the version that we're actually running. So let's actually come back here, kube control get that daemon set -o YAML, and it's the version that we want is 1.17.6. And you can see where actually this pulls it from Amazon's ECR registry. And so we're not changing that. We're continuing to pull it from there. So 1.17.6. We'll grab that. Take the raw version of it, and then come back over here and kube control apply that gist. Cool. So now we'll do kube control get daemon sets in the kube system namespace, and I have 2. Great. Now that one's a 2. So kubeproxy ARM 2.2.2.2 across the board. So now I have get pods -n kube system. I have 4 kube proxies. So next I need to figure out what's going on with these weave nets. Now that we have kubeproxy up and running, we'll grab the pods one more time. And this one just started running, so I think this one will if we just kill it. We could also wait for the crash loop back off, but it's been crashing for a little while now, so that might be a little bit long of an interval. Deleting that pod, the daemon set will reschedule it. Great. So we'll look again, and now I have what this weave net is. We have is 1 of 2 running. Okay, great. So now weave is running 2 of 2 across the board. kubeproxy is running everywhere. Core DNS. I don't really need this AWS node, so let's take a look at the kube system namespace and delete this daemon set. Kube control delete daemon set that -n kube system. Great. So now if we look kube control get nodes, they're all ready. So we have 4. We can scale these node groups up and down using eksctl as needed, because we didn't make any change to the node itself. We only made a change to what was running in Kubernetes. And so if we scale these node groups up and down, new nodes will join with the right daemon set, like whether it's the ARM64 or the AMD64 daemon set, will detect that and run. And I can do like kube control get nodes and match a label selector where I say kubernetes.io/architecture equals ARM64. And that gives me just the ARM ones, AMD64, and that gives me just the AMD nodes. Now, it's important to remember a couple of things here. First is that Amazon said in their documentation here that that it only is supported on Kubernetes 1.14 and 1.15. We're running it on 1.16, or sorry, actually we're running it on 1.17, so that works. It says to use Graviton-based nodes, you have to set up a new cluster. You can't add these nodes to a cluster that has x86 nodes. I mean, that's exactly what we just did. So I don't know if this is supportable or what problems we may run into and why they don't support this right now. Some of these instructions here were useful. They kind of show you how to get that kubeproxy ARM, the core DNS ARM image. Our core DNS, there may be a problem with our core DNS cluster right now. So if we do control get deployment core DNS -n kube system -o YAML, and we look at that, I don't think there's actually a dash in core DNS. So there is an affinity for AMD64. So the way that we have this cluster set up right now, core DNS is going to work across the entire cluster, but core DNS is only going to be running on 2 replicas of it will always be running, but they're always going to be running on x86 nodes, not on ARM64 nodes. So we could create another core DNS replica that had a version of this image that's able to run on ARM64. It kind of looks like they might have a recommendation for that here. If we look at this file, see if there's actually a 117 version of it. There's not. Let's see how they handled it in 115. So they just added a -ARM64 to the image name. It's definitely worth a try. But again, it's core DNS version, not Kubernetes version. So our core DNS is still the same version. So we probably could just modify that and then have core DNS running. And the other thing is when we schedule workloads on the cluster now, I should make this a little bit bigger. All workloads that we schedule on the cluster are going to be scheduled across whatever the Kubernetes scheduler wants to run them on. And that could, right now we have a 4-node cluster, so without any affinity or anti-affinity rules, there's a 50-50 chance, because we have 2 AMD64 and 2 ARM64 nodes, there's a 50-50 chance that pod is going to get scheduled on an AMD64 or an ARM64. In other words, the M5 large or the M6G large instance. If the images in the containers in the pods don't have ARM or x86 compatible images available, it's going to fail to run. Kubernetes doesn't automatically schedule based on the architecture available. So one way you can solve that is if we look at Docker. If we take a look at an example here and we look at the Nginx Docker image, some of the library images, a lot of the library images, and hopefully we see more of this, do publish multiple architecture images. And so we can see here, this image for Nginx has x86 and it has ARM64. So is assuming that, we don't have a preference, it's fine just to run an Nginx on this cluster, and you may get an AMD64, you may get ARM64, and it's going to run fine. But not all. It's important to watch for this. Not all images have ARM64. It's definitely still coming. Yeah, I think that's it. So we have it's an interesting way to start experimenting with Graviton2 nodes, save a little bit of money, get more performance, and have hybrid architecture Kubernetes clusters running in EKS. Thanks.